So in this video, we're going to go over some geometry and trigonometry tips for the SAT and ACT that should help you answer these questions in a quicker way and more simpler way. Before we get there, I want to review interior angles and exterior angles of a triangle, square or rectangle. We'll have a pentagon and a hexagon. So the first thing that we should know, if we can't remember any of these, that the interior angle sum of a triangle is 180. Also, we should know for a square rectangle it's 360. There's always a 180 jump from when you add one side, so that would be 540, and this is 720. So we see here it's plus 180, plus 180, plus 180. This is a three-sided figure. 4 sides, 5 sides, and 6 sides. Just so we know the equation, sometimes you might need, it's n for sides minus 2 times 180. That's the sum of all interior angles. So if we knew in our equilateral triangle these are all 60, if we had to find the exteriors, they'd all be 120. For a square, we know that these are 90, so the outsides are 90. And those are just the two simplest examples, but when we take those simple examples for exterior angle sum here, there is no equation. We just know it's always 360. So keeping that in mind, if we had a problem like this, given the triangle shown below with exterior angles that measure x, y, and z as shown, what is the sum of x, y, and z? So real quick, knowing that we have 3 exterior angles, we could find our sum is 360, move on to the next problem as fast as we can read it. What will trip people up is that we'd have to do certain steps, which I want you to avoid, but just if you wanted to know, we know our triangle sum for interior angle sum is 180. So I'm going to do 180 minus 57 minus 72. That would be 51. And once you do that, each side would be 180 minus the side length, 51, so this is 129. 180 minus 72, 108. Then 180 minus 57, 123. There's other ways to solve this problem. The quickest way is to read it, know the sum of exterior angles is 360, and just to add these up, 129 plus 108 plus 123 is 360. So, next type of problem. So, another topic that I want to go over is Pythagorean triples. What is a Pythagorean triple? So if we have a right triangle, if I saw a right triangle, I didn't know the hypotenuse, and it was 3 and 4, right away I'm going to know that it's 5, because this is called a 3, 4, 5 triangle. If we wanted to do the math, it'd be 3 squared plus 4 squared equals c squared, because I didn't know. 9 plus 16 is c squared, so c squared would be 25, and c would be the square root of 25, which is 5 after square rooting both sides. So there's a lot of cases, and the test always has them. So to make it quicker, I have a little list. So it could be 3, 4, 5, or any multiple of that. for example 6, 8, and 10, where the largest number is the hypotenuse. So this is the hypotenuse, we have a leg and a leg. So, well, you could Google and look up a huge list of them. I'm just going to have this one example and then the multiple of 2 and then 2 other examples. So you could have a 5, 12, 13 right triangle, or a 7, 24, and 25. So keeping that in mind, let's bring this down. Let's copy this right next to our problem. So keeping that in mind, okay. In the right triangle below, the length of AB is 13, which is the hypotenuse. The length of CB is 12. What is the tangent of angle A? So, tangent is opposite over adjacent. In this case, our opposite is 12. Adjacent, we don't know. So, tan of A is 12 over whatever our side length is, AC. Real quickly, I'd either have to do the Pythagorean theorem, or I recognize that it's a 5, 12, 13. Right away, I could plug that in. It would be 12 over 5, opposite over adjacent. Boom, we're done. We can move on as quick as we could read it as well. Next type of problem I want to go over is special, like a line here, special right triangles. So special right triangles, you might learn in geometry, probably more in pre-calc with the unit circle. So there's 2 kinds, a 45, 45, 90 triangle and a 30, 60, 90 triangle. So start off with a 45, 45, not to scale, as best as I can make it. So if you have a 45, 45 triangle, because these angles are the same, the sides are the same. So, and then for always when we do the math, our hypotenuse should be whatever the side length is times the square root of 2. Additionally, we have a 30, 60, 90 here. I'll make it better. Really long side, short side, and a hypotenuse. 30, 60, 90. Our smallest side, we can note it as x. From our smallest side to our hypotenuse, it would be 2 times x. And then our long side would be x times the square root of 3. One thing to note, the larger the angle, larger the side. And with that in mind, because we had equal angles, we had equal sides. So in the example below, in the right triangle shown below, the length of our hypotenuse AB is 8 units. Angle A measures 60 degrees. Sine of 60 is this value, cosine of 60 is that value, and tangent of 60 is that value. Approximately how many units long is BC? Well, we could do our sine and cosine. Again, another quick way is to identify that we have a 30, 60, 90 triangle. The hypotenuse is 8, which means that our small side of 30 would be half of that, which would be 4. And once we get that, our BC side across from 60 would be 4 times the square root of 3, which you'd need a calculator either way. So 4 times the square root of 3, which would be approximately 6.928. So our closest is D. Just to sum up what we did here, we looked at sum of interior angle and exterior angles to be able to answer those type of problems quickly, knowing that exterior angle sum's always 360 of any shape. We looked at some Pythagorean triples and the multiples of them. Again, you can look up a long list of them on the internet. We looked at a right triangle that had the Pythagorean triple to make some quick work there. And then we looked at special right triangles, understanding 45, 45, 90 triangles and 30, 60, 90 triangles. Noting that the longer the side, the longer the side, the larger the angle, or the larger the angle, the longer the side. And then we did some examples. Hopefully that can speed up some of your time on the SAT or ACT, where you have more time to focus on those harder questions.